Hello. Hello. Mic check. Hi friends. Welcome to our first live session on trigonometry problem solving. In this session, we will look at some interesting formulae that may or may not have been discussed with you before, and then look at 10 unique problems I was solving in my trigonometry batch, and I will share my approach and my thoughts on those questions. Without wasting any more time, let's get into the concepts that I want to first discuss with you. So I'm going to refer to my class notes that I had made back in 2007 to help you learn some of the concepts. We would have studied the trigonometric values of multiples of 30 and 45 degrees, right? 0, 30, 45, 60 and 90. It's important from a competitive standpoint exam to also study multiples of 9, namely 18, 36, 72 and 54 degrees. So let's see, sine 18 degrees is equal to root 5 minus 1 by 4 and cos 18 degrees is equal to root of 10 plus 2 root 5 by 4. Sine 36 degrees is equal to root of 10 minus 2 root 5 by 4 and cos 36 degrees is equal to root of 5 plus 1 by 4. From this, we can derive the 72 degrees values because sine theta is cos of 90 minus theta, and same way we can also derive the 54 degrees values with 36. So this is one thing that you should hopefully remember when you are preparing for your competitive exams. The second thing that I want us to learn is the formula for sine A plus B into sine A minus B. Now, some of you might have studied this. Let's look at how this is derived first. I know I can write sine A plus B as sine A cos B plus cos A sine B into sine A cos B minus cos A sine B. Now, when I apply the A plus B into A minus B formula, I will get sine square A cos square B minus cos square A sine square B. And using the identity sine square plus cos square is 1, I can convert this to sine square A into 1 minus sine square B minus 1 minus sine square A into sine square B, And what's going to happen is I am going to be left with sine square A minus sine square B, right? The reason this is useful is because we can rewrite the formula for sine 3 theta, which is 3 sine theta minus 4 sine cube theta, as sine 3 theta by sine theta is 3 minus 4 sine square theta, and I can take 4 common and write this as 3 by 4 minus sine square theta, which I can write it as 4 into sine square pi by 3 minus sine square theta, and this translates to 4 sine pi by 3 minus theta sine pi by 3 plus theta. And this is why this formula is useful. How this results in some other value is tan 3 theta, by doing the same exercise for cos and then doing sine 3 theta by cos 3 theta, we'll be able to say tan 3 theta by tan theta is equal to tan pi by 3 minus theta into tan pi by 3 plus theta. Now, there will be multiple questions that might come in the form of tan 18 degrees into tan, let's do 42 degrees and tan 72 degrees. Now, if we know this formula, we can straight away say that this is equal to tan of 3 into 18 degrees, which is tan 54 degrees, and from the formula that we have studied for sine 36 and cos 36, derive tan 54 degrees, because sine 54 is cos 36 and cos 54 is sine 36. I hope that this formula was something that was useful. Now, let's jump into some of the problem solving pieces. Let's begin with some easy questions first. If A is sine 45 degrees plus cos 45 degrees and B is sine 44 degrees plus cos 44 degrees, then A in comparison to B is what? Whether A is less, greater, equal to, or can't be determined. Now, this is a very interesting question, and the approach to doing this question is not only useful in math, in trigonometry, but is also useful in integration, because you might later encounter some questions by A cos theta plus B sin theta, and you will encounter such questions even in physics, especially simple harmonic motion, when you use vector approach to superpose two SHLs. The way you do this transformation, let me first work with this transformation. I'm not going to do the integration right now, but let me show how the transformation is done so that you get an idea on how to solve this problem. A cos theta plus B sin theta, if I divide with root of A square plus B square and I multiply with root of A square plus B square, I will have root of A square plus B square sin alpha cos theta plus cos alpha sin theta, where tan alpha is A by B. That is, I have essentially formed a right angle triangle whose side lengths are this and this is known, and I will finally get this as A square plus B square into sine of alpha plus theta. Now, in our given question, both A and B are 1. So, I can transform A equal to root 2 sine 45 degrees plus 45 degrees, and I can translate B to root 2 sine 45 degrees plus 44 degrees, which is root 2, because 45 plus 45 is 90, and this is root 2 sine 89 degrees, and this quantity is less than 1. Hence, we can say A is greater than B. It was a fairly simple question. The idea to do this, we get it if we practice more questions based on the similar approach. Let's look at one more direct question. If cot of alpha plus beta is 0, then sine of alpha plus 2 beta is what? And my options given are minus sine alpha, cos alpha, sine beta, and cos beta. Now, I would like some of you to try this problem. Take not more than 30 seconds and come back to me with the solution before I present my thoughts on this question. If there are any specific doubts that folks who have joined us have, please drop it in the chat section so that I can pick them up. Alright, it's given to us that cot of alpha plus beta is 0. Assuming sine of alpha plus beta is not equal to 0, this will give me cos of alpha plus beta is equal to 0. And I can rewrite this expression as sine of alpha plus beta plus beta. Now, if cos of alpha plus beta is 0, I can say alpha plus beta is pi by 2. So, the expression of sine of alpha plus 2 beta translates to sine of pi by 2 plus beta, and from transformation with complementary and supplementary angles, we know pi by 2 plus beta lies in the second quadrant where sine is positive, but since it's a complementary angle, it changes to cos, and the answer is cos beta. It was a simple oral question. Where students get confused is they say a 2 beta, and that's where puts them off, but they have given the relation of alpha plus beta, and to break 2 beta as alpha plus beta is the catch here. Alright, let's look at one more question, which is tan of 100 degrees plus tan of 125 degrees plus tan of 100 degrees into tan of 125 degrees is what? Now, this is also a question that's very common, and there is another version of this question that we had done when I was in my college. Let me pull that up and put that down for you to solve as well, while you try to solve the question on the board. A plus B is 45 degrees, then what is tan A plus 1 into tan B plus 1? And another question based on the same line is tan 70 degrees is equal to 2 tan 50 degrees plus tan 20 degrees, and this is something that needs to be proved. Let's pick the questions one by one. Now, 100 degrees is something that we have not studied. It's not a multiple of 30, neither is it a multiple of 9. 125 degrees, the same thing, right? But the magic happens when you see 100 degrees plus 125 degrees is 225 degrees, which is 180 degrees plus 45 degrees. So I know 225 degrees lies in the third quadrant and tan is positive there, right? So what I'm going to do is I'm going to write this as tan of 100 degrees plus 125 degrees is equal to tan 100 plus tan 125 by 1 minus tan 100 tan 125. And this is equal to 1 because tan is positive in the third quadrant and we are working with supplementary angle of 180 plus 45. So it's equal to tan 45. And when I transform the denominator from the RHS to the left hand side, I will get the answer as this. And finally, I have tan 100 degrees plus tan 125 degrees plus tan 100 tan 125 is equal to 1. And that is my answer to this question. Right? Both the other questions are of the same pattern. If I open the brackets for the second question, I will get tan A, tan B plus tan A plus tan B is equal to what? And I know tan of A plus B is 1. So when I apply the tan A plus B formula, I will finally get that expression is equal to 1. The next question is something that is not A plus B, but rather to work with A minus B. So what we have to do here is we have to write 70 degrees minus 20 degrees is 50 degrees, right? So if I apply tan on both the sides, so I have 70 degrees minus 20 degrees is 50 degrees. Now when I apply tan on both the sides, I have tan A minus tan B divided by 1 plus tan 70 degrees into tan 20 degrees is equal to tan 50 degrees. Clear so far? Now the catch here is tan 70 into tan 20 is 1 because they are complementary angles. So tan 20 can be written as cot 70 and they will cancel out. So this will finally give you tan 70 minus tan 20 is 2 tan 50 degrees, and this is what we had to prove. The entire gameplay is with angles, sum and difference. We have limited formulae. It's about how we are cracking the formulae to put and get what the question is asking. Alright, let's look at another interesting question, which is x by cos theta is equal to y by cos theta minus 2 pi by 3 is equal to z by cos theta plus 2 pi by 3. This is what is given, and we have to find what x plus y plus z is. Again, I leave you folks for a couple of minutes to try this question and then come back to me for the solution. Alright, so if I express each ratio to be equal to some variable lambda, I will get x is lambda cos theta, y is lambda cos theta minus 2 pi by 3, and z is lambda cos theta plus 2 pi by 3. And x plus y plus z is lambda into cos theta plus cos of theta minus 2 pi by 3 plus cos of theta plus 2 pi by 3. Now, cos A minus cos A minus B plus cos A plus B, this is equal to 2 cos theta cos 2 pi by 3, and cos 2 pi by 3 is minus half because it's in the second quadrant, and this half will cancel with 2. So eventually I have lambda into cos theta minus cos theta, which is equal to 0. The question looks complicated, but it is not. We are just using the formulae that we have studied in our fundamental trigonometry class. Alright, let's step it up and do a couple of difficult questions now. X is equal to sine 1 degrees. Then we have to find the value of 1 by cos 0 degrees cos 1 degrees plus 1 by cos 1 degrees cos 2 degrees plus 1 by cos 2 degrees cos 3 degrees plus so on plus 1 by cos 44 degrees cos 45 degrees. Alright? Alright. Take a couple of minutes, try solving this question, and then come back to me if you have been able to get the solution. Right. So when I see a summation problem, the first thing that comes to my mind is a telescopic series. How can we express this in form of a telescopic series is all that we have to try and doing. And they have given the value of sine 1 degrees, but the expressions are in terms of cos. Let's just drive sine into the expression by multiplying and dividing with sine 1 degrees by sine 1 degrees into 1 by cos 0 degrees cos 1 degrees plus 1 by cos 1 degrees cos 2 degrees plus so on till my last term. And I can write this finally as 1 by sine 1 degrees into sine 1 degrees by cos 1 degrees because cos 0 is 1 plus sine of 2 minus 1 divided by cos 1 degrees cos 2 degrees plus sine of 3 minus 2 divided by cos 3 degrees cos 2 degrees plus so on plus sine of 45 degrees minus 44 degrees into cos 44 degrees cos 45 degrees. What we have done is we have introduced the sine 1 term into the expression, and every term we have written in form of the given terms. So the cos 3 cos 2 term which was in the denominator, I have expressed sine 1 of the numerator as cos sine of 3 minus 2 degrees. So this will be 1 by sine 1 degrees into tan 1 degrees plus sine 2 degrees cos 1 degrees minus cos 2 degrees sine 1 degrees divided by cos 1 degrees cos 2 degrees plus sine 3 degrees cos 2 degrees minus cos 3 degrees sine 2 degrees divided by cos 3 degrees cos 2 degrees plus so on, and the last term is going to be sine 45 degrees cos 44 degrees minus cos 45 degrees sine 44 degrees divided by cos 44 degrees cos 45 degrees. So when I actually split each term, I will get 1 by sine 1 degrees into tan 1 degrees plus tan 2 degrees minus tan 1 degrees plus tan 3 degrees minus tan 2 degrees, and this is how we have also introduced a telescopic series into the expression, and the terms keep getting cancelled, and all we will be left with is tan 45 degrees, which is 1. So the final answer is 1 by x. I hope you enjoyed this question. Let's look at another interesting question that I came across is a by b sine of theta minus beta by cos of theta minus beta is c by d. We have to find what AC plus BD, sine theta minus alpha by sine theta minus beta is A by B, and cos theta minus alpha by cos theta minus beta is C by D. We have to find AC plus BD divided by AD plus BC is what? Now, what I'm going to first do is I'm going to write theta minus alpha is A and theta minus beta is B. This is purely from the perspective that I don't want to keep writing such long terms. Sin A by sin B is A by B, and cos A by cos B is C by D. Now, we need AC, BD, AD and BC, right? Let's try getting these terms into the expression. So, when I do 1 into 2, I will have sin A cos A divided by sin B cos B is AC by BD, and when I do 1 divided by 2, I will have sin A cos B divided by sin B cos A is AD by BC. Perfect. There is an important concept in 9th that we had learned called componendo and dividendo, which essentially stated if I have ratio given like this, then I can write p plus q by p minus q is equal to x plus y by x minus y. Essentially, if I also did p plus q by p, I will perform the same operations on the RHS. And that's what I'm going to do here. I am going to write this as sin A cos A plus sin B cos B divided by sin B cos B is AC plus BD by BD. And I am going to write this expression as sin A cos B plus sin B cos A divided by sin B cos A is equal to AD plus BC by BC. And now I am going to divide x by y, and that is going to give me A plus sin B cos B divided by sin A cos B plus sin B cos A is equal to AC plus BD by AD plus BC into BC by BD, and I have sin B cos A divided by sin B cos B. This is what I get when I do x by y. Now sin B cancel, B and B cancel. C by D from our given question was cos A sin B. So this will cancel with this. And I have finally simplified the entire expression to sin A cos A plus sin B cos B divided by sine of a plus b is what is asked to us. Let's simplify this further and multiply with 2 and divide with 2. So I'll be left with sine 2a plus sine 2b into half by sine of a plus b. And we also know sine c plus sine d formula is this. I can write it as half of sine of 2a plus 2b by 2 into cos of 2a minus 2b by 2 into 2 by sine of a plus b. I know 2a plus 2b by 2 is a plus b, so this term will cancel with this, and I have the final answer as cos of a minus b, which is cos of alpha minus beta. And that's our answer to this question. I hope you enjoyed solving this question. The last couple of questions have been a little tricky, and we are stepping up our difficulty level to solve trigonometric questions. Let's look at one simple question now. Cos 28 degrees plus sine 28 degrees is k cube. Then we are asked what the value of cos 17 degrees is. Alright, take a couple of minutes, use the concepts that we had studied and try getting this answer. What we have to do is multiply and divide with root 2, a cos theta plus b sin theta, root of a square plus b square. So I'll be left with root 2 into cos 45 degrees, cos 28 degrees plus sine 45 degrees, sine 28 degrees is k cube. So, and this is cos a cos b plus sine a sine b, which is cos of 45 degrees minus 28 degrees is k cube by root 2, and 45 minus 28 is cos 17 degrees. The reason why I didn't use cos a sine a cos b plus cos a sine b is because that was a plus b, and while solving I realized 45 minus 28 is 17 degrees. So these are the ways you need to break the angles that are given to you to be able to solve some questions that can be solved orally, believe me. It's just that you need the right amount of practice to be able to do that. Alright, let's look at one more question that involves a lot of transformations. I'll give the options so that you understand in what format we have to finally present the answer. So this is a question. While working through Saying Age, I came across this question. I also came across this question when I was solving some material from Bansal's quota during my time of prep. It was a different question, but the underlying concept was pretty much the same. Alright, so I can write this as x by a is cos a, and again I'm going to do that theta minus alpha is a, and theta minus beta is b, and y by b is cos b. So what is actually asked to us is cos square a plus cos square b minus 2 cos a cos b into cos of a minus b. The reason is alpha minus beta can be written as theta minus alpha minus theta minus beta with a minus sign outside, but cos of minus x is cos x, so that's why I've taken the liberty of writing it as cos of a minus b. This very much resembles my a plus b or a minus b whole square formula. Unfortunately, that dirty looking cos a minus b is making all the problems to the question. No problem. I am going to subtract 2 cos a cos b and I am going to add 2 cos a cos b. So my expression translates to cos a minus cos b the whole square minus plus 2 cos a cos b into 1 minus cos of a minus b. Clear? This, I will write this as minus 2 sine a plus b by 2 into sine a minus b by 2 the whole square plus 2 cos a cos b into 2 sine a minus b by 2 1 minus cos 2 theta is 2 sine square theta, and that's what I have done here. Now let me take 4 sine square a minus b by 2 common from the terms. So I am left with sine square a plus b by 2 plus 2 cos a cos b plus cos a cos b. Sorry, I have taken that common. So I am left with cos a cos b. What can we do here to eventually come to our answer? If I give back a 2 to my terms, I have 2 sine square a minus b by 2 and 2 sine square a plus b by 2, I can write it as 1 minus cos of a plus b, and 2 cos a cos b, I can write this as plus cos of a plus b minus cos of plus cos of a minus b. This term and this term will cancel, and I have 2 sine square a minus b by 2 into 1 plus cos of a minus b. Which translates to 2 sine square a minus b by 2 into cos square a minus b by 2 with a 2 sine, and this is 2 cos a minus b by 2 sine a minus b by 2 the whole square, which is sine of a minus b the whole square, which is sine square alpha minus beta. Now I trusted myself to push through the question. As a student, there will be many times where you will be concerned whether you're going in the right direction or not. But as long as you feel that you are simplifying the question rather than overcomplicating it further, just trust your instinct and push through the thought process that you have started. And that will help you come to the right answer. Let's look at some simple questions now. sin A cos B is 1 by 4 and 3 tan A is equal to tan B. We have to find what cot square A is. So I can write this as 3 sin A by cos A is equal to sin B by cos B. So that will give me 3 sin A cos B is equal to sin B cos A, and this term I know is equal to 3 by 4 because sin A cos B is given. So this will give me 3 by 4 is sin B cos A. And then what do we do to get cot square A? Interesting. So if I add these two terms, if I add 1 and 2, sin A cos B plus cos A sin B is 1. That will give me sin of A plus B is 1. That will give me A plus B is pi by 2. I don't know why the color of my pen is automatically changing, but A plus B is pi by 2. I'm just looking at the options that are given to us. We have to find cot square A. I can use A plus B is pi by 2 to write sin A into cos B can be written as sin A because A and B are complementary angles. Sin A is 1 by 4. So that will give me sin square A is 1 by 4. That will give me sin A is 1 by 2, which makes the angle pi by 6. And I know cot square pi by 6 is 3. I hope that you're finding some of these questions interesting and challenging. If there are any questions from your end, please do share. In the meantime, I will try to look at some more questions that we had done from my class notes. Alright, this seems like an interesting question that has elements of quadratic equations into it. Let's do one longish question and take it from there. A cos 2 theta plus B sin 2 theta is equal to C, and this has two solutions, alpha and beta. So we have to find what tan alpha plus tan beta is and what tan alpha tan beta is. All right. Any thoughts on how to approach this question? All right. What I can do is, we have an identity where we are writing the value of cos 2 theta and sin 2 theta in terms of tan instead of the regular 2 cos square theta minus 1 or 2 sin theta cos theta, and I can write this as A into 1 minus tan square theta by 1 plus tan square theta plus B into 2 tan theta by 1 minus tan square theta. 1 plus tan square theta is equal to C. Now, when I transform this equation, I get A minus A tan square theta plus 2B tan theta is equal to C plus C tan square theta. Then I have a plus c into tan squared theta minus 2b tan theta plus c minus a is equal to 0. Do you see the magic that has happened here? By simply converting cos 2 theta and sin 2 theta in form of tan, straight away by simply using sum of the roots and product of the roots, we know tan alpha plus tan beta is 2b by a plus c, and tan alpha tan beta is c minus a by c plus c. The entire catch is to know which formula to apply when. I have not used any formula that we have not learned in our fundamental trigonometry classes. It's all about practice and how well you have been practicing doing the questions. Any questions, any doubts so far? I'll wait for a couple of minutes to look at my chat section. Alright, since there are no questions right now, I'm going to leave you folks with one question to solve, and we can drop in the comment section whether you got this question or not, and then I will post the solution to this after a few days. In triangle ABC, sine square A plus sine square B plus sine square C is equal to 2. We need to figure out the nature of triangle ABC. Example, options are right angled, equilateral, obtuse, cannot be determined. So these are the options, and we have to determine what the nature of the triangle is. I know that solutions of triangle as a topic is not necessarily there in the JEE syllabus. It never hurts to learn that. Having said that, this question is not related to solutions of triangles, it's very much related to trigonometry. Any questions, any queries? Waiting for some comments in the live section. Great. I will see you again for our next live session. I'll take feedback on the topics that you would like us to prepare for in the next session. If you found this topic interesting and if you found this session interesting, drop into our comment section with the word chat, and we will share with you our community that we are trying to build, where we post one question a day on the 3 topics every day, so that you prepare with at least 600 questions before you appear for the JEE exam. Alright, thank you so much. If you enjoyed, do share, like and subscribe.